let's touch on the functionality first. So if you are to simply Google sv40 enhancers or stick this into any of your favorite AI tools and ask them, what do these things do? They are littered throughout the literature as nuclear targeting sequences. They are DNA sequences that move DNA directly to the nucleus, and they're found mostly in gene therapy tools. In fact, Pfizer is on record on a peer-reviewed publication bragging that they did this warp speed process so quickly because they knocked on the door of their gene therapy division to get the plasmid. So when people say, is it gene therapy, you merely have to point them to that paper, that this was pulled out of a gene therapy vector, and it's because this piece of DNA is one of the most effective pieces of DNA at moving DNA into the nucleus so that gene therapy can, in fact, be functional. It also happens to have an unfortunate aspect in that it is known to bind to p53, which is your tumor suppressor gene. Okay, this is the guardian of your genome. You do not want 60 billion molecules injected in every dose that bind to this. Now, we don't know what it's doing to this gene, but go through John's book and you'll get a feeling. There are cancers that are on the rise, and we are injecting people with DNA that shouldn't be there that binds to a gene that's involved in regulatory control over cancer. Here's the shocker, is that we recently were given cancer biopsies to look at this, because our thinking, if you look through the previous literature on this, if you look in all the wrong tissues, you won't find this. You have to think about where are you most likely to find such an event, and in my opinion, that's probably in a tumor, because tumors tend to grow aggressively, and if it happens to be an mutagenesis event, it will overwhelm the tissue in terms of copy number, so you're more likely to find this in tumors. Let's go looking under the lamppost here. So we got a colon biopsy from a group in Germany that we've been working with, and we were quite shocked by the results. This is a person who was vaccinated 4 times by Pfizer, 1 year since vaccination, tumors emerged, person was dead within a month. We got 3 biopsies out of them, 1 postmortem. All of them have sv40 in the origin of replication from the Pfizer vaccine. We performed some sequencing, which we're going deeper on right now, but even that preliminary sequencing shows this is in fact Pfizer's vaccine. We have enough sequence. There's sequences in there from Spike and other places. Now, what is shocking in this work is we were never expecting to find the DNA at a copy number greater than the human genome. Like if you get an insertional mutagenesis event, and that is a driver mutation, that means that tumor starts taking off. The insertional mutation should be at the same copy number as another human gene. What we were expecting to find is something where maybe 10 or 20% of the tumor actually was mutated, and therefore it would come out later on PCR than our human gene. We're seeing the opposite here. This is expanded inside the patient, and that if we're getting signals in PCR that are so hot that it looks like we actually amplify the vaccine directly from the vial, and that's impossible. That means after you inject someone with 300 microliters, this person got 4, so 1.2 mLs, you should have a 64,000-fold dilution into their body, so we should see a 6 CT shift in where this PCR signal comes out from dilution alone. We don't see that. We see something. Means after you inject someone with 300 microliters, this person got 4, so 1.2 mLs, you should have a 64,000-fold dilution into their body. So we should see a 6 CT shift in where this PCR signal comes out from dilution alone. We don't see that. We see something where it's coming in at the same concentration as the original vial or higher. That tells us the DNA is replicating. That tells us that the mammalian origin of replication that's in Pfizer's vaccine is active in human tumors.